Hi everybody, so this is our test 3 review. I'm sorry that I couldn't do this in class, that I had to do the video, but as you know, if you've listened to the emails, not really feeling great. Obviously tested for COVID this weekend, so just kind of on the recovery, hopefully on the recovery anyway. In any case, I'm quite tired and not feeling 100%, but I wanted to get this done now while I could. So let's get started. First question says, show all work. Use the properties of limits to help decide whether each limit exists. If a limit exists, find its value. So this question is a limit as x goes to infinity. So the basic idea, there's a shortcut I'll show you, but the basic idea is that you divide each term by the highest x in the denominator. So the highest x in the denominator right now is x power 2. So I'm going to divide every single thing by that. So the top, if I divide every term in this by x squared, that'll be a 3. The next one, if I divide this by x squared, will leave 2 over x. Sorry, I'm already messing up my words here. Divide this term by x squared, you get a 5, and then you get a 2 over x, and then you get a 1 plus x squared. So just to take one consideration here, for example, this one, the reason why it cancels out to a 3 is that if I divide it by an x squared, because that's the highest power in my denominator, you can see that the x's cancel, leaving just the 3, which is why I get this 3 here. Okay. So the reason we do that is now if we do the direct evaluation, all of these are going to become infinity, which are huge numbers, which are basically going to make all 3 of these terms go to 0 because we're dividing by such a big number that it essentially destroys the number. And what we're left with is 3 over 5. So that's one case for limits. I'll do the second case, which is number 2, and then I'll show you a shortcut for these questions. So number 2, show all work. Use the properties of limits to decide whether the limit exists. If the limit exists, find its value. So once again, this is a evaluation as x goes to infinity, which means we want to look at the highest power in the denominator, which is x to the power 4, divide everything by that. So we're not evaluating this yet. Just divide every single thing by x to the power 4. You'll see that this is 7 over x then. You know, if you wanted to do this by hand for each term, you can look in the notes to see how I used to do that. That's 4 on top and 4 on 3 on top and 4 on bottom. 3 of them cancel and leaving 1 on bottom. So you've got 7 over x. And that's why I have this 7 over x up here. So for 4x over x to the power of 4, it's cubed. That's 8 over x to the power of 4. This is going to be 7. This is going to be 5 over x. And this is going to be 2 over x to the power of 4. So take your time with those. All of these evaluated in infinity basically give us zeros. And we have a problem here. This also gives a 0 actually. I'll make that gold so you see it's a different type of 0. When you evaluate this thing, you essentially end up with a 0 on top and a 7 on bottom. Now 0 divided by 7 is perfectly fine. Like, there's nothing wrong with that. What I mean by that is if you say 0 divided by 7, it doesn't give you an error, it just gives you 0. So the answer to this is going to be 0. So I gotta turn my phone off here. There's a lot going on in my life at the moment. So we got a 0. Boop, 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 boop. And then that would be the answer that you would give. You would say the answer has an answer, which is 0. It's not that it doesn't exist, it does exist. The answer would be 0. Now, I could have also asked the limit as x approaches infinity, but the top power could have been bigger. So in the notes, I did give a shortcut for this. But basically, there's 3 cases. You're always looking for the highest power in the denominator. If the top power is bigger, so the top power biggest, that's the first case. That's if you had like x cubed plus 2 over x squared plus x. It doesn't really matter. This is the limit as x approaches infinity. The important thing is that this power on bottom is actually not as big as this one, And if you evaluate this, if you have this case the top power is bigger, it's always going to give you an infinity, okay? The second possible case is if the bottom power is biggest. And what that means for us is, for example, on the top you might have squared term as your biggest power, plus x. It doesn't really matter what these terms are. Let's just say this is 3x squared. And this is like 4x power of 3 plus 2x or something like that. It really doesn't matter what the other things are. The most important thing is that the biggest power is on the bottom compared to the top. That's always going to evaluate to a 0. Okay? So if the top power is the biggest, it's going to give infinity. If the bottom power is the biggest, it's going to give 0. But if we have the same biggest powers on top and bottom, this is only for limit as x approaches infinity, remember. You might have something like 7x cubed plus 2x squared or something, and this might give you like a 3x cubed plus 5x or whatever. It really doesn't matter. The most important thing is that the bottom and the top powers are the same. The sort of cheat here is you just take the coefficients and that's your fraction. So you could do all these the longhand way, but really this would give you a 7/3 as the answer, because it's the coefficients that are in front of those same biggest powers. And I actually had that case before. So this is like a little cheat sheet for you. If you just, on a test, if you were just to tell me this case, or this case, and jump straight to these final answers, I would be okay with that. But the first case here, you can see we had the same biggest power, so we took the coefficients. It was 3 and 5, right? To make it obvious, the coefficients in front of those same biggest power, x squared, 3 and 5, you can basically skip all the steps inside and just give the final answer. And then number 2, you can see that the bottom power was bigger, and so anytime the bottom power is bigger and we're going x to the power of infinity, or x goes to infinity, we're going to get a 0 out of that. If the top power was bigger, we would get the infinity as our final answer. Okay, let's move on. Find the derivative of the function using the definition. So I'm going to rewrite this one. To the side here, so that I have some structured work paper here. So the definition is the first derivative, also known as y prime in this case, doesn't really matter, is going to be the function with x plus h in it minus the function itself, the original function, all over h. And I always forget the limit for this for some reason. It's the limit as h approaches 0 of this. Now the formula sheet, this would be on the formula sheet. If you just take a look at the formulas, you should have these printed before the test. This is the definition of the derivative, so you can see that I've written down the same thing. Oops. Sorry, my energy levels are really low today. I apologize. So what this means for us is our derivative, y prime, which is the same as saying f of x, f prime of x, it's going to be the limit as h approaches 0. I'm going to take this function, but I'm going to be putting x plus h in for all those x's. So this is 2 x plus h squared minus 3 x plus h, and then I'm going to subtract the function as it is. I'm going to subtract this. But the thing is, I'm basically subtracting out the whole function, so you've got to make sure that you are multiplying through by that negative. That's probably the hardest part of the question, to be honest. And then this is all over h. So this is the limit as h approaches 0, and I've got to expand all those brackets. So that's going to be the longest step, I would say, for sure. So to expand this out, this is 2 times, and this is a standard expansion. This is x squared plus 2hx plus h squared. I've just foiled that. So this piece here is just a basic FOIL, and if you want to do it on the side to make sure you got it right, you can do that, but it's always going to be equal to this. Minus, and then of course you've got to multiply through both of these, so be very careful with that. That's minus 3x and minus 3h, and then multiply through by this negative. You get minus 2x squared and plus 3x. Just be careful with these signs, please. It really makes a big difference. And the bottom is going to be h. Now we're not going to evaluate this limit until we're done. So we need to keep expanding, keep expanding, keep expanding. Multiply, multiply, multiply. And if you want to right now, you can actually see we've got some things that are going to cancel. These are, for example, like terms, but they're opposite signs. So you could cancel those out and make your expression a little smaller. So let's keep going. Don't put in the h until the very, very end. This is going to be 2x squared plus 4hx plus 2h squared minus 3h minus 2x squared, and this is all still over h. And what we'll find now is that things are going to cancel once again. This 2x squared and 2x squared are going to cancel, and we're left with this 4hx plus 2h squared minus 3h all over h. And the top has a common h now. We gotta factor out h. So let's do that. The limit as h approaches 0, I can factor out a common h on top. It leaves me with 4x plus 2h's minus 3 all over h, and then those are finally going to cancel off. My denominator will no longer give me a 0. That was the whole problem. If the denominator was 0, it would have given me a limit issue. It would have been undefined. Now I can just get the limit as h approaches 0 of 4x plus 2h minus 3. And essentially what that does for us is as h approaches 0, it's going to take this term, fire it to 0, and we'll be left with 4x minus 3. And that'll be our final answer. So I recommend if you're having any issues with this topic, you go back into the notes. We did a page or two on this stuff, and we did a very similar example to this one. This is also asked on your assignment, as you know. So this is what it looks like when you do the definition of the derivative. And you must do the definition of the derivative on this thing. Like, it says using the definition right there in the question. And if you read the fine print here, it says show all work. You will receive no marks if the definition of the derivative is not used. And the reason I put that there is that, of course, we have derivative rules now we can use for this. Like, if you just use the power rule, y prime is going to give, 2 comes down, multiplies by this, you get a 4 and an x, and then this x disappears here, it becomes 3. 4x minus 3 is the same answer, but we didn't use the definition. So the whole point of this question is to make sure you know how to use the definition. Okay, so just be careful with that. Now number 4, it does not say use the definition, it just says find the derivative. So you can use the power rule. So all that means for us, bring the 3 down in front, reduce the power by 1. F prime is going to be 3x squared. That's our final answer. That's a gimme mark. I gave you that basically to build your confidence a little bit. Number 5, find the derivative of the given function. We need to rewrite this piece because we need it in power form before we get the derivative. So this is 4x power 4 plus 6x cubed plus x to the power of negative 2. Now the negative 2 is the new part. It used to be positive 2, but when you get the reciprocal, it becomes a negative. Now I'm going to get the derivative of all that. And now the power rule and everything applies. So that comes down, that multiplies, and so on. So this is 16x cubed plus 6 times 3 is 18, x squared. This is technically a 1 in front of the x, and anything with an x on it gets rid of the x when you get its derivative, so that's a 1. And then here the 2 comes down, gives us a negative 2, and reduce the power by 1 is negative 3. So this is actually fine the way you see it here if you wanted to end here, but you could also end it like this. Where the 2 stays on top and the x comes down as a reciprocal and you change its sign again. Both of these are perfectly fine. No need to no need to rewrite it if you don't want to. Number 6. Find the derivative of the given function. For full marks, simplify your result. So this question here, question 6, is actually kind of another gimme question. It's easy if you know how to do it. These 1 over 13 fractions, 1 over 3. They're just constants. They don't affect anything. So when you get the derivative, they stay where they are. And then it's the x terms that are going to be affected. So the 13 comes down for the x13, becomes x to the power 12. And 1 over 3 stays where it is, but the power comes down and becomes 3x squared. These, just to be clear with the colors, they didn't do anything. They didn't change anything. It's the x's that got modified using the power rule. And the fancy thing that happens here is that the constants are going to cancel. 13, 13, 3, and 3. And the final expression is significantly simplified. And that would be what I want. It says, in fact, in the question, find the derivative of the given function. For full marks, simplify the result. This is what I mean by simplify the result. Make sure you get rid of those fractions. Moving on to number 7. Find the derivative of the given function. Now this is a root. So if it's a square root, cube root, anything like that, we need to rewrite first in what's called power form. So that means make the root into a power, and that's easy. It's just a half. So the derivative, y prime, you bring the power down, multiply by the 8, 4 times a half is 4, reduce the power by 1. This is a perfectly fine answer. You could leave it like that if you want to. But the question does say type an exact answer using radicals as needed, so if you really want to follow that instruction, which is a good idea, bring it to the bottom. It's x to the power of a half, and then really anything to the power of a half is a root, so it's root x. And there we have it. Moving on to number 8. Evaluate the derivative of the following function at the given point. So when it says evaluate, it means put in x and y. Evaluate these two things together. Basically means substitute in the x value after you get the derivative. Substitute the x value into the derivative. So get the derivative first and then put the x in, and you'll get the slope at that point, also known as the derivative. So y prime is 4x minus 4, and I want to put in the x value. So 4 times our given value, negative 1 in this case, minus 4. It's negative 4 minus 4, which is negative 8. So the slope of our function when x is negative 1 is negative 8. I'll show it on Desmos, but I'm just trying to do this as fast as I can, so sorry about that. I don't have the same sort of energy as a normal day. So number 9, use the product rule to find the derivative. So product rule has a very specific formula. You can find it on the formula sheet if you don't know it off by heart. But I recommend you memorizing it. It just means y, if you have two functions f and g multiplied by each other, your derivative is going to be the derivative of the first one times the second one, and then the first one, the derivative of the second one. Some students, like I know Michael in class, thinks of it like this, f prime g plus g prime f, and for some students that is easier because the derivatives come first. Just make sure to swap the function. Whatever way you slice it, this is going to be our f and this is going to be our g. So y prime, derivative of the first one is 6x, and the second one just gets multiplied by it. Use brackets if it's more than one term. So we can see 5x and negative 4, those are two terms. So make sure you use brackets. Plus the first one, 3x squared plus 4, and the derivative of the second one, g, is 5. And you should expand this because there's not a lot to it. So open up the brackets. This is 30x squared minus 6 times 4 is 24x. 5 times 3 is 15, x squared, and 5 times 4 is 20. The middle terms, wait, this and this will combine. Those are the highest terms, so that's 45x squared minus 24x plus 20. And it doesn't get more simple than that as far as this course goes anyway, so that's going to be where we leave it. Moving on, find the derivative of the function using the quotient rule. So the quotient rule, once again, is on the formula sheet. You can take a look at it. I'll bring it up for you. If you have two functions, one over the other, then it's going to be f prime g minus f g prime, or f prime g minus g prime f, all over g squared. And remember, there's a minus in the middle here. So that's what I'm going to do. The top function is our f. Bottom function is our g. And what am I doing? Derivative of the top is 8x. And the bottom, again, has two terms, so make sure you multiply by that. Minus the top thing is 4x squared plus 5. The derivative of the bottom is 2x. And the bottom is x squared plus 7, and then that's all squared. And you should expand the top. So never expand the bottom. I've said that a few times in class, but just when you're doing the quotient rule especially, please don't expand the bottom because it will just make things messy. The top should simplify nicely for the questions that I give you. So the top here is 8x times x squared is 8x cubed plus 56x. And then we have minus, right, it's basically negative 4x squared times 2x and negative 5 times 2x. If that's not messy enough to look at, I'll just erase those, but that's the idea. You should get negative 8x cubed, and negative 1 times 5 times 2x is negative 10x, I think. Certainly hope that's right. And then on bottom we have x squared plus 7, all to the power 2. So things should cancel, boop, boop, and we will get 56x minus 10x is 46x, and x squared plus 7 all squared. That's our final answer. A little bit messy there today. Just going to have to apologize for that one. Not at full energy today. So, 11. Find the derivative of the given function. Oh, before I go any further, I should mention there is an expectations document that I emailed you, and there's 17 questions on the test. So it's actually a shorter test, but it's because some of the questions are longer than we're used to. 1 second, I gotta plug this bad boy in here. Okay, find the derivative of the given function. For full marks, simplify your answer completely. So this question, because we have something in brackets here with a large power, essentially that is a hint for us to use the chain rule. And the chain rule, the constant stays outside, 2.25. The power is going to come down off the brackets. The inside is going to stay the same. The power is going to reduce by 1, but the inside will stay the same. And then multiply by the derivative of the inside. So let's not forget that the derivative of the inside is the whole point of the chain rule. That gives us negative, this is 3 times negative 6, so negative 18x squared. I think that's right, looks okay. And then you've got to do 2.25 times 8 times negative 18. You can even include the square if you want, and then that'll give us our answer here. So let's see, bring up the calculator here. 2.28 times 8 times negative 18, negative 324. So y prime is negative 324 x squared. That's out of 7 minus 6x cubed power 7. And that's our final answer here. So when it said in the question to simplify your answer completely, it was talking about the green parts. So the constants multiply because they're easy enough to multiply. Don't multiply anything out that has a power on the brackets because that's not going to be easy or useful. Number 12, find the derivative. There's a hint that any power to the n of x is going to be x to the power of 1 over n. So, for example, if it's a square root, it gives a power of a half. If it was a cube root, it would give a power of a third, and so on. So this is a power of a third, can see that right here. So the whole thing, if we rewrite it, is going to be the same expression inside, but it's all to the power of 3, 1 over 3. And that turns into another chain rule, or a general power rule. So what does the chain rule do? It takes this power, multiplies it by the first, it comes down, multiplies by what's there, and then we reduce it by 1, and then we've got to make sure that we get the derivative of the inside. So let's do it piece by piece. The derivative, it's 1/3 times 3, which is 1. So 1, the inside never changes at the same step. 1 over 3 minus 1 is negative 2 over 3. Use a calculator if we need to. And then the general power rule states, so we get the derivative of this piece now, which is 2 times 18, 36x. And like the last one, any outliers, kind of do some housekeeping, these constants need to multiply by each other. So this is 36x, 18x squared plus 8 to the power of negative 2 over 3, and that's okay the way it is. For this topic, just because there's so many powers and things going on, you don't need to change the negative in the exponent, but if you wanted to, you could. Hey, 1 second, what's this 12 doing here? Let me see if I made a little mistake here. 1 over 3. 1 sec. So I just checked the work. I can't for the life of me find out. I can't see where my mistake is. The answer Pearson wants is 12, and I'm getting a 13. Sorry, 36. I have no idea. I just cannot find it. Like, even if I rewrite this, for all I can see, I feel like it would be this. And both of these are fine. If you find the mistake, could you please email me and let me know? Just on the test, just do it to the best of your ability. You're not going to see the problem, I guess. But I can't see the mistake here, and I don't know. I've looked at it for about 5 minutes now. I don't know. So if you find it, let me know, but I don't think there's a mistake there. Differentiate the given function. This is a special case where we have a product rule. So with f and g, but we also have chain rule because we have that expression to the power of a half here. So we're going to do the product rule. This is u prime, I suppose, but it doesn't matter. The derivative of the first one is 2v, and keep the next one the same. Plus the first one as it is, v squared, and then the derivative of the second one is going to be a half comes down, keep the inside the same, reduce the power by 1, and then the derivative of the inside, this is the hardest thing for a lot of students, they forget to get the derivative of this, which gives a 6. And then tidy this up. The really only thing you need to tidy up is this. These need to multiply together. Everything else is honestly just fine the way it is. 6v minus 1 plus this, a half times 6 is 3. So that's where that came from. v squared, 6v minus 1, to the power of a negative a half. That's okay. I'm telling you that negatives in the power are okay for derivatives, just because they do still give the proper slope, so I'm not too picky about it. And if you wanted to rewrite this, this is pretty much what I would expect. So you could keep the constant on top, bring the 6v minus 1 down, and turn it back into a root, if you wanted to go that route. Little pun there. There you go. Those are both fine, and Pearson has its own version of what it wants to do, but that just combined like powers, and it did a common denominator sort of thing. We don't need to do that. That's the end of question 13. So question 14, remember there's only 17 questions, so there's 4, 5, 6, and 7 left, 4 questions. Let's see what number 14 has in store. Suppose that x and y are related by the equation. This is definitely an implicit situation because y is mixed in. The y is the big issue here. It's kind of in the middle of the expression. It wants us to determine dy by dx, which I'm going to relabel as y prime because it means the same thing. The change in y with respect to a change in x is our derivative y prime. So just get the derivative here. The derivative piece by piece. So the derivative of 3x squared, 6x, The derivative of 2y squared is 4y, and it pops out a y prime because of the chain rule for implicit differentiation. And the derivative of a 4 is going to give us a 0, because derivatives of constants give 0. Now solve this for y prime. So I'm going to keep the negative 4y, y prime on the left. I'm going to bring the 6x to the other side. You could have brought the y terms to the other side if you wanted and kept the signs positive. It doesn't make a difference at all. And remember, we're looking for y prime, so we need to divide out everything that's not y prime, which is negative 4y in this case. And see what happens. Cancel, cancel. Negative 6 divided by negative 4 gives us a 3 over 2. So this should give us a final answer of 3x over 2y. Excuse me. 3x over 2y. That's question 14. Moving on to question 15. Find all higher derivatives of the function f of x equals 5x plus 3 all cubed. So this is kind of a multiple chain rule question. F prime, remember we need to, this is general power rule, also known as the chain rule. 3 comes down. In front, the expression stays the same. It's reduced by 1, making it a 2. And don't forget to get to the derivative of the inside of this, which is 5. Now, the tricky thing about these, we should really multiply these together, like expand it and simplify it as much as possible before going any further. So this is 15 outside of 5x plus 3, all the power of 2. Now, you can do the general power rule again. So for the second derivative, it's the same story repeated. So the 2 comes down, multiplies by the 15, right there. Trying to make a blue there. 15 times 2, what's that? That's 30. Inside stays the same as 5x plus 3. Power is reduced by 1, so now it's just 1, so we don't write it. And it's still times 5, so 30 times 5 is our next piece of the puzzle there. 30 times 5 is 150. So I've done this question before on the assignment. I've done all these before on the assignment. But that's our second answer. Now some students would expand this here. I really want to suggest that you expand it before getting the third derivative. So f double prime, I'm not getting another derivative, I'm just expanding it to make it easier in this case. 150 times 5 is 750, so it's 750x, plus 150 times 3 is 450. And then I'm going to get the third derivative, okay? Now, that was a rewrite, that was an expansion. Now it's the third derivative, and that's just a simple power rule, so 750. So the hardest part of this question, in my opinion, is getting the third derivative. A lot of students get it wrong. But if you take your time to make sense of what I just did there, pause the video, go back and watch it again or something, you should be okay. It really comes down to expanding this before you start this part. Before you start the third derivative. That's question 15. Question 16, the displacement in centimeters, displacement S in centimeters of a linkage joint of a robot is given by this expression, where t is the time in seconds. Find the velocity of the joint for t equals 8.75. Now, let's just remember, velocity, if you want, it's not asking you clearly what it is, but it's the first derivative of displacement. Velocity is s prime. S is the displacement. The change of displacement is velocity. Like rate of change of displacement is velocity. So just get the first derivative of this function. I'll put them all together here. So first derivative, this is a general power rule, also known as the chain rule. So 2 over 3 comes in front. Inside stays the same. Are you seeing the pattern yet? I hope so. Reduce the power by 1, which is negative 1 over 3. And now the derivative of the inside. Just be careful here. The derivative is going to give us 2 terms, okay? So if you get the derivative of this, it actually is 2 pieces 7 and minus 2t. So make sure you use brackets when you have 2 or more terms to multiply. But that's basically it. There's nothing to expand here. The question said it wanted this velocity when time is 8.75, so that's what I'll do. I'm just going to put time of 8.75 into this, and I'll show it on my calculator. You can show it on paper if you want. Let me bring up the calculator and show it. So that I'm just going to tap it in. Let's see. 2 over 3 bracket 7, and then I want 8.75 in this, minus 8.75 squared. Close the brackets, be very careful to put this in right. Power of negative 1 over 3, and then 7 minus 2 times 8.75. Again, make sure you close all the brackets appropriately. And I've got 2.8189. Let's see how many decimal places it wanted. It wanted 2 decimal places, so 2.8189 is 2.82. What are the units? I guess it doesn't matter. Oh, it does say here centimeters per second, so 2.82 is all it wants, and it takes care of the units for you, which is very convenient. 2.82. There we go. And just a little tip, almost a cheat, but something to check your work if you want to. Remember that your calculator, if you have this one, does derivatives for you. Do Shift and hit this calculus button. It sets up the derivative. It says, tell me the derivative, tell me the function you want the derivative of, and tell me the point that you want the derivative at. So 7, I'm going to call it 7x minus, oops, I should probably open the bracket, minus x squared, close the bracket, power 2 over 3. So this is the expression you want the derivative for, and you want to tell it to evaluate it at 8.75 in this case. And it gives the same answer, 2.82. So if you just want the 1 mark, you don't know how to get the derivative by hand, but you do want the mark, you can give me the final answer and I'd give you 1 mark out of 3. Question 17, last one. The displacement in meters of an object is given by the following function. Okay, find the object's acceleration when t is 4. Well, acceleration is the second derivative, and I'm going to put time equals 4 into this. So the first derivative is 2t plus 1. The second derivative is 2. So what it means is that it's a constant. So if your derivative is constant, that means that no matter what time you have, in this case time 4, it doesn't really matter, it's going to be still 2. Because there's nowhere to put that t. The acceleration is not going to be 4. It just means the acceleration at all times, no matter what the time is going to be 2 meters per second squared. So that's the entire test. I managed to make this recording in about 38 minutes. Now, of course, if you like double the amount of time, that brings it up to a little over an hour. But I guess what I'm saying is, if you know what you're doing for this test, you should be good to go for time. You probably won't need the 2 hours. Let me know if there's anything I can help you with. I can't guarantee I'll be able to get back to you because this week is going to be a bit strange for me. But I hope this helps a lot, and I just really wish you all the best in this test. And I will email you as to what we're going to do for the rest of the week. Okay, take care. Have an awesome test, and hopefully I'll see you soon. Bye-bye.